So I let you take the stage. You can share your screen in the button.
That was
next to the task button.
So yeah, thank you for organizing this after indeed the event at the high-tech campus some months ago. Some different data. The key is, yeah, we're into nano-patterning, which is nano and micro-patterning, which you need for MicroLEDs and displays. And the key is to do wafer-scale, nano-pattern and micro-patterning with very low distortions and very high reproducibility in order also to facilitate wafer-scale and micro-LED integration. My name is Marc Verschuuren. I'm the CTO of SCIL Nanoimprint Solutions. Yeah, please contact me afterwards if there are any questions or comments, and yeah, we can share the slides. Short introduction on SCIL. So we do, as said, wafer scale, nano and micro patterning. We're a relatively young company, although the technology has been developed for over 20 years in Philips research. We're a spin-out with strong technology and partners like IMEC Expand and RSBG, a German deep tech fund, and we have 2 Dutch financial funds. We also ran in the Intel Ignite startup scale-up coaching program, which was very valuable. We aim to provide really a solution to the customer. So not only a tool, but really a customer-specific process to take the risks out for the customers. So what the customer would like, we optimize the materials, we can optimize the tooling and the process there. As said, the technology has been developed for more than 20 years. It's actually been used for making VCSEL lasers and nano patterns on that since 2008. 2 customers that are open or MockStack, they're using it to make polarizers, wire grid polarizers and metal lenses, and Terramount for wafer scale optics for chip interconnects. We like to work with you, and we also like to work together closely with our suppliers like VDL and Lab14, who help us with building the hardware and also to give support there. So what is the need for micro and nano patterns for, in this case, micro LEDs? Nano templating allows you to go for a full nitride RGB system. Normally, red and green has difficulties to grow in nitride, in indium gallium nitride, because the materials don't fit on each other. By going nanoscale templating, you can make fully relaxed, efficient green and red LEDs. There are also several companies who are exploring this. Light extraction, normal LEDs like power LEDs or so, they use micro-scale structures to extract the light. Well, this is almost the size of a micro LED, so therefore these are not efficient. So you want to go to something that is called photonic crystals to have an efficient light extraction and also beam the light so you get more usable light. And then you have your optics, the secondary optics or primary optics, depending how you call it. Standard lenses are very thick or need organic materials which are not resistant to the high temperatures and light fluxes, and therefore you can go for these flat, fully inorganic, thin metal lens structures, which are composed of nano resonators to shape the wavefront. But these have to be, well, actually in all these applications, the structures have to be typically sub-100 nanometers and with single nanometer accuracy for it to work reproducibly. How we do that? How do we make these patterns? We're using a stamp, a rubber stamp that we make from a master, which originate once with optical lithography or e-beam or combinations. You can make many stamps from this master, and then you just press it into a liquid resist. Material flows in, you cure it, you release the stamp, and you